Hello everybody and welcome back to this new video. Today we're going to be talking about this new Linux box from CyberSecLabs. This is Pipercoin. This is a pretty difficult box and let's jump into the Nmap scan. So our Nmap scan is pretty minimal. We only have port 22 open, which is SSH, and port 80, which is HTTP. Now from these two ports we're going to first check out port 80. So from going to the IP, we notice that we have this Pipercoin website, we have PiperNet here, we have Pipercoin here, with some information and an about page. Now, whilst we check out this website, it's always useful to have some automated recon running in the background. So let's do that using wfuzz. So we're gonna fuzz this website, 72.31.3.10. Then gonna have our fuzz there, and this has to be a -u. There we go. Then we are going to use the word list user share word lists and dirtbuster and big.txt. And then let's see what happens here. So if we run this, we will notice it's going to start fuzzing, and we can see, okay, for places that don't exist, like this one, the result is 2000 characters long, so we can remove all the results, we can hide all the results with that character amount. So let's do just that with --hh, and then it was 2123, I think. Is that correct? Yes. Okay, so now it's going to start fuzzing for everything that doesn't return that amount of characters. So that's great, and this is going to take a while, but I've already ran it. So if we do cat commands fuzz, wfuzz, yep, there we go. We notice that we have three pages: the about page, which we already knew about, this newsletter page, and the site page. So let's jump into checking those out. So if we go to the site page, we see we get some seemingly source code of this website. This is a Flask web app, and that's good to know. So we can take the source code and put it in Sublime Text so we can view it easier and let's jump into examining this source code. So first of all, we see it's Flask. It uses some kind of API that we probably can't get because this is Pipercoin and the name of the box is also Pipercoin. So it's going to make a Flask app, and then here's something interesting, the secret key. So the secret key is going to get it from the environment, but if it doesn't exist, this is the secret key. So possibly we have the secret key for the session tokens. So that would mean that we can sign our own session tokens and get input that way. Okay. So then next we have this function calc, which is going to do an exec, but without any built-ins. Now if you don't know what built-ins are, stuff like len is a built-in in Python, import is a built-in. So those functions, without them, an exec of this expression. Okay. Then we have this firewall function, which wraps this function. That's going to do a whole lot of stuff. Okay, so we'll dig into that in a second because here we have the routes. So the first route is /Pipercoin, and this is where our firewall function is going to get run. Okay, so then we have the site, which we just went to, and some other pages that aren't important for now. So okay, we know if we go to Pipercoin, we're going to run all of this code. So first, it's going to get the data from that API that I talked about. It's going to get stuff from the session, the name and value. So okay, so right now I'm going to consider this as input. Why? Well, we may have a working secret key for the session. So right now this is input for me. So then it's going to generate this expression, which is going to equal name to value. Okay. The length has to be over 20. It's then going to find all of these forbidden characters, so we cannot use these, I guess. Okay, the expression, yeah, it cannot match that because else we're going to return 404. The length has to be below 300, okay? And then we're going to run this calc on our expression. So okay, so we have input that's going to get executed here, if the session token is actually a session token. So first things first, let's check that out. So let's see, if we go to this Pipercoin page, Pipercoin, okay, we notice, yeah, we get a session token here. So we have our session token, let's decode that. And for decoding Flask session tokens, I always like to use Flask unsign. This is a really great command line tool. So yeah, use this. So let's go back into our command line and make this a bit smaller so that this is bigger. And then we can get started with Flask unsign. So we're going to Flask, first of all, we're going to set our token to be equal to this token that we just got. And then we're going to do Flask unsign. We're going to -- decode, because we want to decode this token, and then -- cookie, and then supply our token. And we see, okay, so this is actually still from when I was testing before. So let's quickly regenerate this token. So we're going to delete this. Delete session. Did that work? Okay, maybe, I think we got a new token now. Let's see if we set token equal to this. And then do our decode. Okay, there we go. So now we have this as our token. We have, and the reason that this internal server error happened is because when I removed the token, it couldn't find one, so it threw an error. But now if I reload and I have a token, it's gonna work. Okay, so we see, okay, we have a name and a value variable that's set in our token here. Great. So what do we want to do right now? We have a potential secret. So we want to see if we sign this token, or if we change this, sign it, and put it as a session token here, and reload the page, what will happen? Either it will crash because, well, it's not correct, the secret is not correct, or either it will work, and that means, hey, we did a great job and we have the secret, and we can use that input to get into that exec. Okay, so let's test that out. So first of all, we're gonna select something as our cookie. So our cookie is gonna be, let's say, this, and then we're gonna add a field here. Is working, and we'll say, okay, that's gonna be true. So now we have a new token. Now we want to sign this. So we're gonna do Flask unsign again, and this time we're gonna do -- sign with our -- cookie. And then we need to grab that secret. That secret was this one. So copy that. -- secret. And we'll put this in single quotes because this has some weird characters that Bash might interpret weirdly. Let's see where we have an issue here. So -- cookie did not work. Let's put this between quotes as well. Still an issue here. Let's see what this issue might be. So our cookie is set like this. Let's actually remove these quotes maybe. No, that's not gonna work. Yeah. So we need to have these quotes, and then we also need to have the quotes here. And that the error is this doesn't work as a cookie, I suppose. Oh, we have triple dashes there. That's the issue. Okay. So now it's gonna work. Yep, perfectly. So now we can take this session token and change it here and see if it works. And this did work. So that means, hey, we have the right secret. Now to prove that, I'm going to change the secret. So I added a letter to the secret, changed it. And now if we input this and we reload, we see, okay, we get an internal server error. So that was not the secret. So this is the secret, and we can put input in there. Now, okay, we can control input, and we have an exec here. That's going to run on our input. However, we don't have any built-ins. So what does that mean for us? Let's take a look at that. So we're going to go into a Python shell here to show what's going to happen. So Python, and we're going to say, okay, we're going to do an exec. Let's do a print of 1 + 1 or 2. Okay, and then here we want to set our built-ins to 0, to none. There we go. And we can run it. And we see, okay, we get output here. What if we try to import something here? Like, for example, we would want to import OS on the server. We can notice, okay, __import __ not found. And that's because we don't have these built-ins. So we cannot really do anything. We could try going into a new exec here. Okay, exec. Let's do this first. So is this gonna work? Yeah, let's use slashes here. That still works, but if we import here again, import OS, that's not gonna work again. Okay, so that is a bummer. However, there are ways to get around it, and you could find that out by Googling a lot, and you could find this Stack Overflow, for example, is an exec string built-ins none, a secure way to execute user input. And it obviously isn't. No, it's not a safe practice, and we can use this to get around it. So let's see. So this is gonna go into underscore class base subclasses. It's gonna find something, and that's gonna bring back our import, and then we can execute something. So let's test this out, see if that's gonna work. So instead of this import os print, we're gonna paste this in. This uses quotes as well, so we need to backslash all of these. There we go. Over here as well. Okay, I think that's all of them. And then we're going to change this shellcode to be like an who am I? We have an invalid syntax here. I suppose that is because I use single quotes here, so let's just change this to be double quotes for the exec. I think that will fix it. And there we go. Okay, so now we have executed code. We have done a who am I in our exec without any built-ins. So that's great, right? So now all we have to do is put this in our cookie, sign it, and then it's going to get executed, right? So we could say, for example, if we set the name to that, and then we have a hashtag at the end to comment out the value, then we have code execution, right? No, why not? Well, we have these forbidden characters that we have to pay attention to. So these ones are not allowed. So what do we do? Well, we have to find a way around them. Now, what you might think is, what happens if we just input the hex code for them? Is that going to get blocked? And the answer is no, it's not. So we can do just that. So I made this script here. And it's pretty much going to make it easier for me to show all of this. So first of all, it's going to take input, and that's going to be the command. It's then going to get a payload for that command. It's going to generate the token with our Flask unsigned, so nothing new here. It's then going to make a request to Pipercoin with our cookie. It's going to get the cookie back out of the result of that request, decode it with Flask unsigned again, and it's then going to show us the result. Right, so this is very simple, just automatically doing what we would else have to do manually to make it faster for us. Now, okay, let's take a look at this here, this get payload, because here we have our signs that are not allowed, our characters that are not allowed. So what am I going to do? I'm going to replace them with their hex variants. Now you might wonder, why is there so many backslashes here? I'm going to explain that in a bit. And why am I replacing this single quote? I'm also going to explain it in a bit. So basically we have here our string. This is our first example that I showed. So this is going to just import, get import back, and it's going to run a system command on that with the hashtag at the end. Then we have this for I in range. It's going to loop over every character, and if it finds one, it's going to replace that with the appropriate hex variant. So let's see. What would happen if we hadn't replaced that? Well, let's see. It would throw a 404 HTML if one of them was found. So in order to be able to see that, we're going to print or result request.text so we can see what happens. Okay, let's get into this. We're gonna do we're gonna run our shell. What happens if we input ID? We see, okay, we get a page back, and this page contains this present word and this yesterday word, which looks a lot like our page here, yesterday present. So okay, we know that worked. Right, we replaced those values, and that worked. Now if I comment this out and just return the string there, so now we're not replacing all of that, we'll notice that we get a 500 internal error even. So some error happened. So okay, we know now we can replace all of those forbidden characters, and we can get around that, which is great. So then let's get into explaining why we have so many backslashes here. So first of all, you need to see that these backslashes are going to get halved every time we use them somewhere. For example, just by having these as a string here, once they're loaded in and used into our command, they're going to be halved, because this backslash is going to backslash this backslash is going to backslash this backslash, and so on. So then, once we've reached our payload, we already have only 4 backslashes left. Okay, and we can show that by printing out our payload here. So let's print out our payload, and it's going to get 4 backslashes. But then we're going to run a OS command. This OS command is also going to have our payload in it, so that means we're going to remove, again, half the backslashes. So that means that after our, so let's print out the session here as well, so we can show that. After that, in our session, we'll only have 2 backslashes left. Print session token. Okay, so let's show that off. So we're going to run our shell, type something, and we see here, okay, we have 4 backslashes for every character that's not allowed. Perfect. Then we have our token here. If we decode that, we have to set the token variable first. Token variable. If we then decode that token, we'll see, okay, we only have 2 backslashes left anymore. And where does that last one disappear? Well, it happens here when setting this expression. We're going to set our name, which has the 2 backslashes, and that's going to get, those 2 backslashes are going to backslash each other, and we're going to end up with 1 backslash and our hex value here, which means that this is going to end up being there, and that's going to get converted into a dot. So that's what we want. And that works just fine. I know this explanation might be a little bit here and there and everywhere, but check it out on your own. Try this box out, because it's a very good box to learn some good Python skills, and so check it out yourself if you don't fully understand it. So okay, we have that. We got across that. But if you noticed, my script didn't actually work. Now, why is that? Okay. Let's see. Or my script did work, and we did get execution, but we have an error here, and that's because, well, we don't have any way to get output from it, right? So this worked. We got this page back, but where's the output? It's gonna execute this command, but it's never gonna use here in the exec. It's never gonna use any output. It's not gonna return anything. So how do we get output back here? Now we can get output back. Let me quickly remove these print statements here. We can get our output back by, for example, setting the session token again, so that we can get the session token back and then view our output there. So how are we going to do this? So we have to change this statement here, and I did that here. So if we look at this one, so we still have our exec, we still have our getting our built-ins back, right? And what we are going to do here is we're going to import Flask. We're going to then set the session token x to be equal to, then we're going to import OS, and we're going to run a system command. So now we're going to change the session token to get some result back. So let's test that out. So we're going to run our shell, we're going to do ID here, and we notice, okay, we get some result, but it doesn't contain anything, and this value x is being cut off by my script. So I'm going to actually print this whole result here. So we're going to print the decoded session token. But something good that we already noticed, this x variable has been set. So that's great. So let's see. Okay, and we see, okay, x is, here, x is equal to 0. Why could that be? Why is x equal to 0? Well, that could be because this system command here is not returning anything. So what can we also do? We can also do, and I'm doing it here, popen.read. Or actually, this might fail for another reason. This might fail because our string is too long. But I don't think it actually is, because else we wouldn't get any result back here. So let's go with the first thing that I said, that maybe system is not returning anything. So what we're going to do is we're going to do popen.read. So let's popen, and we're going to do our command and then do .read on that. Okay. So that's another way to get command execution with OS. Let's see if that works. we notice, okay, now we get something even weirder. We don't have set cookie in our result. So now we come to what I said earlier. Maybe our payload here is too long. Why is that? Well, down here it said, okay, if our payload, if our expression is longer than 300 characters, we are not going to run our calc, we are going to return. So let's see what the length of our payload is at this point. So down here, after we get the payload, we'll print the payload, the length of it. Okay, let's run that. We see, okay, our length is 433. But that's not actually true because we still have those backslashes that are going to get removed. Oh, but still, our length is way too long. Like as you can see, these 4 backslashes are going to all get turned into 2, so that's going to remove a lot of the length still. But this length is still way too long. And, well, our exec statement is looking pretty cool, but we notice that here we have a long string catch warnings, and that's just kind of strange. It's all very long. It's written out in a too long manner. So let's see if we can shorten this. So let's pick this biggest part here. So let's take this part and see what that gives us and what we could maybe do with that to make it shorter. So this gives us, this is going to loop over all of these subclasses and check for a name that's equal to this. Now maybe we could make this shorter by taking a look at all the classes. So we're going to remove this if here. We see, okay, we get a lot of stuff back, but this is an array. So if we can find the index of this warnings catch warning class, then that's going to help us a lot already. So let's do a for I j in, and we're going to enumerate over this here, over that, and then we can print the index and the j dot underscore and the name. So now we have to just find the catch warnings name. Okay, so if we print that, we see, okay, we have a lot of stuff here, and here we have the catch warnings name as at index 59. So now we had this, which gives us that, but we can shorten that by removing all of this and just saying, well, 59. That gives us the same result. So that's great. So that's pretty much, we have already shortened it by a lot of characters here. So let's incorporate that into our thing. And I even think that this for C and C is not needed anymore. If we remove that. Yeah, see, that's not even needed. So we've shortened it by almost half, this part. So that's great. So let's incorporate that into our script here, and that's just what we did here. Okay. So with that, we can try to run this. This has all of the improvements that we made. It has the short version. It has the Flask session that we're going to be setting. And it also has the popen.read here at the end. So this script should hopefully work. And is hopefully short enough. So let's run this. Run this, and we can do ID. And we notice, great, we get our result back. So now we have code execution on the box. Now this script, we can also obviously do it manually by printing the payload, unsigning it ourselves, signing it ourselves, and then going to the web page and decoding it. This script just makes it easier for me and also to run commands, because this is kind of a nice little web shell or whatever you want to call it. So now we have code execution on this box, and it seems like we are already root. So we now have a shell, and the shell says that we are root. However, that seems a little bit strange, because if we do a ls-la of the root directory, we'll see that there is a .dockerenv file. So this means that we are in a Docker container here. Now looking at the rest of the files, this Piper database folder directory seems quite interesting. So let's take a look at that. So we're going to ls that, and we see, oh, there's a database in there. So this database might contain credentials, might contain anything interesting for us. So let's make sure that we can get it. And in order to get it, since we're in this bad shell, this kind of web shell that we've created, let's convert this to base64 so that we can then convert it again back at our own box. So for that, we're going to do base64. We're going to then do -w for rep, and we're going to set rep to none, because we don't want it to wrap, we just want it to be one big block of text. And then we can do SQLite 3. So okay, now we have this base64 string, that is our database. So we're going to copy that. I'm going to quit this. And we're going to then echo our string and pipe it into base64 -d for decode, and we'll put that into a file. So now we have this file A, and this file A is a database, an SQLite database. So now we can open this with SQLite. And let's see if I can get this up there. Yeah, let's make this bigger. So I can do .tables to view all the tables in here, and we see there's a table called credentials. Okay, that seems perfect. So let's select everything from this table, credentials. And we notice, okay, we have a list of emails, usernames, and passwords. Okay, so what I did is I took all of these passwords and usernames, put them in files, so I'll show that. So we can .quit to quit, get out of here. We can catch the users, and we can get the passwords. So these are all the usernames and passwords. And now we can try to brute force them. Now earlier we saw that only port 22 was open and port 80. So, well, port 22 is then maybe the port that we want to brute force at this point. So for brute forcing it, we're going to use Hydra. We're going to do -l for our users, -p for our passwords, and then we supply the IP address, and we supply SSH to make sure that we're attacking SSH. So that is going to run and should give us a result soon. Yes, and it did. We have Jared has the password OG original Jared, so it's a compliment. So we have a valid SSH login. So that's great. Let's SSH as Jared on this box 31.3.10 with this password. And we have a shell as Jared. Perfect. And this Jared is also the user, and we have the access.txt file. So that was it for user. Let's move on to root. So here I have my shell as Jared here, and if I do an ls-la, you will notice that there is this cryptoKeys file, and this cryptoKeys file is very interesting because root is the owner of this file, and it has the SUID bit set. Now what does this SUID bit mean? It means that anybody who runs this file will run it with the permissions of the user for who this bit is set. So this bit is set for the root user. I can execute this file, I am Jared, but if I execute this file will be run as root. So that's very interesting. Also, because we have read permissions on this file, so maybe we could exploit this file in some way. If this is a Python file, we could maybe inject a module, something like that. But let's see what kind of file this is. So this is a 32-bit executable. And in this executable, well, we might find more interesting information, and we can read it. So let's get this executable to our own box. For that, I am going to use netcat. I'm going to listen on my local machine here on port 1234, and we are going to pipe that into, let's call this file A again. And then here we can connect to our IP address, .8.1234, and then we can input the cryptoKeys file. I forgot to listen here. Okay, so run that again. I'll notice, okay, that worked. And now we can take a look at this A file, and we have it here. So perfect. Now this file, we have to reverse engineer. We have to make sure that we know what is going on in there. So for that, I use ghidra. Ghidra is very great because it can analyze our file, and for the function, it found a main function. So if we take a look at the main function here, we see that this binary expects two parameters. If it has two parameters, if it has less, then it's going to show this information, else it's going to do show keys. Now 2 parameters, that means the first parameter is always going to be the name of the script, and then the second one is actually the first parameter, if that makes sense. So to show that, if I run this file, run cryptoKeys without any parameters, now it has only one parameter, because this is also one, which is very confusing, but I hope it makes sense. And it's going to output that text. However, if I supply something else, then it's going to run this showKeys function here. So let's take a look at the showKeys function. So this is going to take in our input, and it has a buffer of 304 here, and it's going to copy our input into this buffer. But our input was never checked for its length, and this is also not going to check. So here we already have a buffer overflow. So this buffer can be overflown, and then we have a lot more information, but at the end we have a return. So we have a classical buffer overflow here. Now let's see how we can exploit this. So first of all, let's check what kind of security bits are set for this binary, so that we know what we can do and what we can't do. So for that we're going to do checksec on our cryptoKeys binary. cryptoKeys. Checksec is just going to show us what we can and can't do. So for example, the stack canary is not there, so that means that we don't have to worry about overflowing the stack. We can just do that. And the NX bit is disabled. That means that we can put shellcode on the stack and then afterwards jump to it to execute it. Pi is enabled, which would make ROP or return-oriented programming a little bit harder, but I don't think that's needed because we have an overflow and we have NX disabled. So that's great. We saw that there is an overflow, and we saw that we can pretty much put shellcode on the stack and execute it. But first of all, we have to find out how do we trigger the overflow. Well, we have to input more than 312, I think it was, characters. So let's do that. So we're gonna do this with Python. We're just gonna print a, and let's print it like 400 times. That should overflow, and it did. We get a segmentation fault. Okay, so that's cool. We know how that works now. We can get an overflow, but now what we want to know is we want to know the offset of our overflow. How many bits, where does it overflow? Where does the return address point to when it overflows? So we can input our own address to our own function there. So for that, I'm going to go into a Python shell and I'm going to import everything from pawn. It has to be the other way around, obviously. From pawn, import everything, because we are going to use pwntools for this. Then we can make a cyclic string of, let's say, length 400. And this string we can input into our binary, and then we can check where is our instruction pointer at the point where it overflows, and then we can find that string back in our original string here and get the offset of that. So let's do that. For that we are going to use GDB. I'm going to do -- args. First argument is going to be our file, cryptoKeys, and then the second argument is going to be our long string. So let's run that. Okay, if we run this, we'll notice, okay, we get the sig fault, we get the overflow, and our instruction pointer here is at DAAD. So we can copy this string, go back into our Python here, and we can do cyclic _ find with our string, and it's going to say, okay, the offset is 312. So now we know that. Now we can get started maybe with writing a script that's going to help us do all of this. So I'm going to use ctf-py to make myself a solve.py script here, very simple. And we can start by putting our offset in here. So our offset is going to be 312. So that means that our padding is going to be, let's just pick A times 312. So what is then going to follow? What do we still need? We need the address to jump to. So that's going to be an address on the stack. That's going to be something. Then we are going to add a nop sled. A nop sled, nop is an instruction that's going to do nothing and skip. And it's always nice to add a lot of those. So if you jump to the wrong stack address, but it's an nop sled, it's going to just slide right into your shellcode, which is going to follow next. So next we're going to add our shellcode, which is going to be something. And then we have our full payload, so we just add everything together. We add the padding, add the stack address, we add the nop sled, and we add the shellcode, and then we print our payload. And that's pretty much the basis of our script, but we still need a couple of things. So first of all, let's get the stack address here. And for the stack address, there might be an issue, because if ASLR is enabled, then the stack address is going to be variable, which obviously would mean that we would have to leak the stack address somewhere in the program, which is harder, but it might be possible. But let's first check if we need to do that. So to check if ASLR is enabled, we need to cat/proc sys kernel and then randomize VA space. So this returns 0. What does 0 mean? 0 means ASLR is fully off, and so every time we run this program, the stack address is going to stay the same. Now that's great, but well, from running this program and overflowing it, so let's quickly do that. We're gonna run this program and overflow it. /. Well, we don't get the stack address back, right? So the stack address may stay the same, but well, if we don't get the stack address back, then is that useful? Well, luckily, GDB is on this box, so we can just use GDB with --args again, overflow the program, and then see where the instruction pointer is pointing towards. So okay, we're gonna run our program. We get the segmentation fault, and now we can do info registers to get more information. And let's take a look here. Our instruction pointer, or our stack pointer, that's what we need, is at this address. Okay, perfect. So now we know, well, and I can show that it's always going to be the same, because if I run this again, so yes, quit that. If I run this again, run it, do, was it info registers, we see, hey, this address stayed the same. Okay, so the stack address is always going to be here. That's beautiful, because we can use this address in our script as the address here. But I cannot just input this address like this, because then Python is going to turn it into an integer, and this. So we need to turn it into some proper bytes that can be used. So for that, we're going to import from pon import everything. Right, so then we can use p32 to turn this into proper bytes that can be understood. I use p32 because this is a 32-bit binary. Okay, so knowing that, the only things left is our knob sled and our shellcode. Now for that, I am going to use shellcraft from pwntools. Now this is quite difficult to understand, so definitely suggest reading through the documentation. But for our knob sled, what we are going to do is we're going to get some shellcode. So for that, we can use shellcraft, and then we can say, okay, I want a knob. So this is just an instruction that does nothing, and then we get the assembly for that. And the same thing for the shellcode. So we're going to also use shellcraft, and we are going to get a shell. So .sh is going to try to give us a shell. But obviously, this shellcraft function, it needs to know more information about what we're running, because, well, is it 64-bit or 32-bit? What's the OS? What's the arch? So we need to give it that information. And to do that, we can say context. We can set the context. The arch is going to be i386, and the OS is obviously going to be Linux. Now, how do I know this? Well, if you look at our checksec from earlier, if I can scroll up to that, it said it here as well. So that's how you could find that. Okay, so now we pretty much have this that might work. So if we execute that, solve.py, we have an issue that we cannot concatenate bytes with strings. We are running in Python 3. Let's change that to Python 2 so we don't have to deal with that. And there we go. We have a string here now. So this is our payload that we want to execute. But I notice there's one issue. I notice this this 90 here, which is my my knob sled. And I notice there's only one of them. And well, it wouldn't be a good sled if there weren't a lot of these instructions. So let's add. Let's say we add, well, let's add 100 to start with. So okay, so now you notice we have a lot more of these. All right, so I don't like that these are in text. So let's see if that gives me any issues in the future. But it seems like there's some other bytes that are also in text, and maybe just because they cannot be displayed. But okay, so we have our payload, so let's put that in a file called payload. And now we want to run this payload on the box here. Now, to do that, I started my Python server here in this domain, and then what we can do is we can just run the binary here. So /cryptoKeys. And then we can say, okay, as the argument, take the result of curling from our Python server the payload. Now, if we run that, we will notice that, okay, the address did not match our records, but we don't have a sigfold, we have this hashtag here, which means that we have a shell as root. So I went pretty fast over this pawn part. If you have any questions, as always, leave them down below in the comments for any part of this video. If you have any feedback, please give it to me. I hope you enjoyed this, and I hope to see you back for another video. Take care.